current of the power supply times the, what's it called? No, it's not, hold on. It's over, the epsilon sub not over the current of the power supply
Equals what?
equals the impedance.
Okay. So following this parallel, I'm going to do an intermediate step before what Ibrahim said. So that's Ohm's law, AC style. For a capacitor, it's the voltage across the capacitor is, or the amplitude of the voltage across the capacitor is equal to the amplitude of the current across the capacitor or through the capacitor times
The capacitive reactance.
There we go. Together we got it. And for an inductor,
Current times the inductive reactance.
and for the power supply,
Current times inductance. Current times the impedance.
that's the word.
Impedance.
We have a formula for X of C, 1 over omega C. We have a formula for X of L, the capacitive inductive reactance, which is omega L. And we don't have a formula for the impedance because it is problem specific. All right. Let's see if we can do this without going down the wrong path. I know that when we got epsilon here, probably should be a 0 there. When we got our power supply voltage phasor, it was the sum of VR and VLC. I use Pythagorean theorem over there. So epsilon squared is equal to VR squared plus VLC squared.
So, are we doing both V and LC here? Or
It's
is
V-
it
well,
we choose? Because I remember you saying that we can pick one or the other, but.
Yeah, I just lumped them into a VLC. It's one or the other.
Okay.
Yeah, I didn't. You could just do VC or VL, but I'm just indicating that it's the same. Both that should be epsilon of 9. All right, I know based upon what we have over there. Sorry, we've done something a little bit different here, but. I kept epsilon sub naught. Why did I do that? Oh, because I was actually solving for the current across LC. Oh, okay. I am going to make that substitution. I might go back though. So that's power supply times the impedance is equal to IR times R squared plus. Now I've got this combination here. I have a voltage VLC, which is either this or this. I mean, these are equal to each other in this particular case. I know that ICXC equals ILXL. I know that the is this torn between just sort of running with it and making sure I don't take a misstep. this step. Sorry. So I did that, yeah, that's all good. All right. So we need to somehow figure out what that is. All right, so that is going to be the current that's flowing through LC times sort of making up a new capacitive reactance. It's some unknown here. There's some, I mean, in essence, how do you add reactance in parallel? That's sort of what we're faced with. Well, ILC, that's this current right here, that current that flows into it, is just the difference between it. I know that that current flowing into that LC structure is equal to IL minus IC. I know that IL is VL over XL minus VC over XC, which is, well, VL and VC are the same thing, so that's VLC times 1 over XL minus 1 over XC. Therefore, VLC is equal to ILC times, this way, divided by 1 over XL minus 1 over XC. So all I did was I took this and I divided both sides by it, and got VLC by itself. So this right here, this XLC, well, it's like adding resistors in parallel. It's the reciprocal of the sum of the reciprocals. Except there's a minus there. Come back. So this is the current out of the power supply times the impedance squared is equal to the current out of the resistor times the resistance squared plus the current flowing into the LC structure times 1 over XL minus 1 over XC to the negative 1.
I have a question.
Yep.
Before we did all that, the VL over XL minus VC over XC, what formula did we change to get there?
When we got to here,
No, the one right before it.
This
How
one?
did we set that up? What?
all right, so ILC, the current that's flowing into the LC structure,
Mm-hmm. Very low.
is, well, I had IC this way, IL that way, so the combination of the two is just IL minus IC.
Mm-hmm.
So I started out with, so ILC, because I got that bugger right there,
Mm-hmm.
is IL minus IC. Now, this is the current flowing through the inductor,
Yep.
and using this rule right here, if I solve for it, it's VL over XL.
Oh, if you did, okay.
And then the other one,
Just the other formula.
yeah,
Okay, that makes sense.
okay. And that is an L, and that is a C.
And
So,
is there a negative sign in front of those parentheses in that LC?
oh, there?
Yeah.
No. Just a straight mark. Good. Now, we have this current flowing out of the power supply. This is the same current that flows across the resistor, which is the same current that flows into my LC parallel structure. So that's squared. Also squared over here too. So this current, and this current are all the same. So I end up with Z equals the square root of R squared plus 1 over XL minus 1 over XC to the -2 square root of all that.
You say -2's,
It's a C there. Sorry, Jack, what was that?
sorry, I think I discharged it wrong. You said that, what does to the -2nd power mean?
Oh. If I have a to the -2nd, that's 1 over a squared.
Oh,
So if you don't like the negative exponents, then you would write the square root of r squared plus 1 over XL minus 1 over XC squared.
I've just never seen a -2.
It's just shortcut. It is common math notation, that's not just a me thing.
You're making it.
I make up half the stuff, but not that one.
Good to know.
The views. Okay.
This is. Let's go.
You got washed. Questions?
Seeing a lot of letters, no numbers.
Yep. It is sort of an alphabet soup. If the alphabet composed of maybe half a dozen letters. And looking at my notes, part of the initial problem was to find ILC in terms of the other things that we know. But, so that was throwing me doing notes of what I was trying to do here. It shouldn't have, but it did. How dare you. All right, I'm about to erase AC currents. I know, it'll be sad to see them go. And we're gonna tackle something else. We're gonna talk about why Maxwell got so famous, besides just adding a term to Ampere's equation. Any questions before I make this go away? This go away.
Is this the end of the chapter?
Yeah. Chapter 23.
So,
Instead of my remembering later, that's 28, 23. Where did I leave off that I will regret later not? We did that, skip that, didn't talk about that.
Half the chapter just there.
I think you'll pick up that which I left to skip over. And if not, you'll ask questions. So why don't we just go ahead and make it official? Today is the 27th?
correct.
Yes.
So I think the next 27th is when we'll turn my master's up.
The next 27th?
Yes, probably.
What do you think I would get then? I suspect it would be fewer than if we just made him do it a week. So, master set 23 and a homework quiz 23. A week from today.
23?
Yeah.
23. Chapter 24.
Not enough time in the day.
Well, if you stop working in a restaurant all the time.
Stop making hot dogs.
I put in my 2-week notice 3 years ago. It was